Hello, third grade. Today we're going to look at chapter 5 of the solar system. The title of this chapter is called The Brightness of Stars. The big question for this chapter is, why do some stars appear brighter than others? When you think about stars, what comes to mind? You may think of tiny points of light you see in the night sky. Have you ever thought about which star is closest to Earth? You also might think the sun, even though it looks bigger and brighter than other stars. Although the stars in the night sky seem very different from the sun, they are all stars, and they all have certain characteristics in common. Stars are space objects that give off their own heat and light. But why do some stars seem brighter than others? It is because some are closer to us than others. Or do some actually give off more light? Brightness changes during a star's life cycle. One reason that stars are of different brightnesses is that stars change over time. Stars differ during these changes by age, size, and temperature. They all begin as clouds of dust and gas, but they change over the course of billions of years. Stars follow predictable patterns of change as their matter and energy proceed through the reactions that make them glow. Eventually, all stars die. Stars progress through a life cycle, and their brightness changes too. The sun is classified as a yellow dwarf star. It is a medium-sized star. Yellow dwarf stars last approximately 10 billion years. Most stars in the Milky Way are classified as red dwarfs. They are smaller and cooler than yellow dwarfs. Many are so dim they can't be spotted without powerful telescopes. The star named Rigel is a blue giant, 25 times larger than the sun. Blue giants use up their energy relatively quickly and become cooler red giants. Brightness is both apparent and absolute. Imagine that a ship is approaching a lighthouse at night. From far away, the light appears small and dim to the ship's crew. However, as the ship gets closer to the lighthouse, the light apparently seems bigger and brighter. The light's brightness has not changed. A star's apparent brightness is how bright the star looks when viewed from Earth. But stars of different ages, sizes, and temperatures actually give off different amounts of light. Some are truly brighter than others. Scientists have established a measurement called absolute brightness that identifies how bright stars are when viewed at the same distance. The standard distance used for this comparison of stars is 32.6 light years. A light year is the distance that light travels in 1 Earth year. Light travels very fast. 1 light year equals approximately 6 trillion miles. A star with a high degree of absolute brightness can appear dimmer than a star with absolute brightness. If the brighter star is much farther away, many of the tiniest points of light in this telescope photo have greater absolute brightness than the stars that look brighter only because they are closer to Earth. What are the brightest and closest stars to Earth? The sun, of course, is the closest. It is approximately 93 million miles from Earth, or 8.3 light minutes. The sun's apparent brightness is so great that no other stars are visible from Earth's surface facing the direction of the sun. Proxima Centauri is the second closest star to Earth. It is 4.2 light years away. If you look at Proxima Centauri through a telescope, the light you see was given off by the star over 4 years ago. The light that is Proxima Centauri is producing right this moment will not be visible from Earth for over 4 years, which is fascinating. The star that appears brightest to the unaided eye in the northern hemisphere is called Sirius, or the dog star. Scientists know Sirius is an extremely large, bright star. It appears brighter than Proxima Centaurus, even though Sirius is almost 9 light years away. What kinds of things were you probably doing when the light now is visible from Sirius and you'll begin traveling towards Earth?